All right, so this is going to be a video all about figuring out the antiderivative of 1 over x. Now, normally what I would suggest doing is turning this into a power expression, this x to the negative 1, and then you can use reverse power rule. So using reverse power rule, you'd end up with x to the negative 1 plus 1, and then dividing by that same power there plus c. But if you do this, you end up with dividing by 0. This was covered in a previous video. So you cannot use reverse power rule when n is equal to negative 1. It will not work. So there has to be some other way to figure out what the antiderivative of 1 over x is, and that's basically the whole premise of this video. So let's start with a shortcut way of doing this. Shortcut way of doing this is remembering that the derivative of ln x is equal to 1 over x. So if the derivative is this way, that means the antiderivative would have to be this way. Derivative is going to the right. If you're going backwards, you're going to the antiderivative. So the antiderivative of 1 over x, therefore, would just be equal to ln x. It has to be absolute value. We'll talk about that in a little bit. And since it's the antiderivative, you always need that constant of integration. So that would be the shortcut of figuring out what the antiderivative of 1 over x is. But how do we know this part right here? How do we know all of this? How do we know the derivative of ln x is equal to 1 over x? Where does that come from? This next part of the video, I'm just going to show you where that comes from. All right, so say you have the function y equals ln x. And we're trying to figure out the derivative of y, which is ln x. Because remember, I just said y is the derivative of ln x equal to 1 over x. Again, that's what I'm going to show you right now. So first thing I'm going to do is, I can't really do anything with this blue equation right here, so I'm going to base e both sides, and you end up with e to the y is equal to x. Now remember, the whole point of this, we're trying to figure out dy over dx. So to figure out dy over dx, well, you're going to have to take the derivative of both sides with respect to x using implicit differentiation, and then this dy over dx is going to come out for us to solve. I'm going to take the derivative of both sides, so the derivative of e to the y, and take the derivative of x. Remember, again, I said that the dy over dx is going to come out. It's going to come out right here. So the derivative of e to the y is itself e to the y, but the y does not match the x. If you remember the implicit differentiation rule, that means you have to multiply by dy over dx, which is good because that's what we're trying to solve for. This is going to be equal to the derivative of x with respect to x. That's just going to be 1. So now if we solve for dy over dx by dividing both sides by e to the y, you're going to end up with dy over dx equals 1 over e to the y. But the derivative of ln x is supposed to be equal to 1 over x. Why is it equal to 1 over e to the y? Well, if you notice right here, e to the y is equal to x. What you can do is you can substitute that in, and now you have the derivative of ln x being equal to 1 over x. Again, the derivative of y, this y right here, the y is equal to ln x if you look at this blue right here. So that is the derivative of ln x, which is equal to 1 over x. So the derivative of ln x is equal to 1 over x. So if you're, again, going one way, for the derivative, it's 1 over x. But if you're doing the antiderivative, and I'm actually going to solve that really quick right now, is I'm going to multiply both sides by dx. So that's gone. And I'm going to do the antiderivative of both sides, which, again, this is what we're looking for here. This integral symbol and this d right here are going to cancel. You're going to end up with ln x plus c, because you are doing an antiderivative, you have to have that constant of integration, is equal to the antiderivative of 1 over x dx. Now, if you remember before, I said that you have to have that absolute value bars over the x. Now, the reason for that is you can't take the ln of a negative number. It just doesn't really make any sense. If you tried to work it out, it wouldn't work out. So because of that, you have to make sure that it's always positive in there. Now, 1 over x can have negative numbers for x. So this right here could have a different domain than this here because your x could be negative or the original expression, but once you do the antiderivative with the ln x, you can't have a negative there. So you have to have those absolute value bars there. Real quick, why you cannot have a negative value for the ln. Let's just say that we have ln of x equal to y. If we did base e both sides, this would cancel. You end up with x equal to e to the y. Now, if you notice, this e to the y is always positive. Okay, this is always going to be greater than 0. That means this x, because it's equal to it, is also going to be greater than 0. That means x has to be positive. It can't be 0 either. It'll never be equal to 0. So this right here is the reason why you have to have the absolute value bars. So that's a video all about the antiderivative of 1 over x. If you have any questions about anything in this video, let me know.